Okay, in my previous video, I've shown you how to use the main core Machina library in Visual Studio and how to write a program in which you can create a new virtual robot, you can generate a set of actions, you can tell the robot sequentially what you want to do, and then right after, you can export all that sequence of actions into a program that you can manually load into a physical or a virtual robot and then execute it as a pre-compiled program, right? However, as discussed before, one of the nice things, one of the main advantages of using Machina is that Machina can actually work in real time with robots. It can connect to robots, maintain a live connection, and then do a very similar operation where it can stream in real time all these actions one at a time. It can listen to the state of the robot and it can make decisions based on that particular state. And what's also interesting is that the API, the way you do that, is very, very simple to the offline programming mode. You only have to change a little bit of the configuration of how Machina is working internally. So that's what we're going to do right now. So we're going to take this example file that I just wrote in my previous video, where I created an offline program to move the robot to a particular position and then trace a vertical square in space and then go back. This program right now works in offline mode because it's the default mode for safety reasons in which Machina works. But we're going to make very small changes in order to turn this program into a real-time connection and real-time control program with in this case, with a virtual robot. So let's go ahead and do this. The first thing that I would like to highlight is the fact that in parallel, I created a robot studio simulation with a virtual controller and a virtual robot. You can see my previous videos on how to do that. And we have used so far this virtual robot to manually load a program to the controller, a program that we had pre-compiled from either Machina for Grasshopper, Machina for Dynamo, or writing it in Visual Studio. And then once the program was loaded, we can just execute it and the program will run in a cycle. So the program that I just downloaded is the one that I did in my previous video, where I move to a location, I rotate, I then trace a square, and then I go back. But this is a pre-canned program. There's no live connection between this robot right now and any other software in my computer. So what I want to do is I want to use this particular robot, this simulation, to be listening in real time to my Visual Studio console app that I wrote before. So there are many different ways we can do this, and it depends very heavily on which brand of robot you're using. But in this video, I'm going to showcase this for ABB robots. So, and the really nice thing about Robot Studio in particular is that when you create a virtual robot like the one we are seeing in the screen right now, you can use it for loading programs offline, but also this robot that we have in the simulation right now is behaving as if, literally, as if there was a virtual robot connected to my local network in my computer right now. So what that means is that this robot as a device is visible to Machina in the local network, just as it would be if I connected my laptop through an Ethernet cable to a physical robot, to a physical ABB robot, or if I connected to the robot via a local network somewhere. What this means is that I can use this particular simulation in Robot Studio as a local connection to Machina, and then I can stream stuff in real time as if it was the physical robot. This is not the case for other brands of robots, so this is actually very nice from ABB in particular. If it was a different brand of robots, so for example Universal Robots, we would need to be physically connected to the robot to be able to stream these actions in real time. So what I'm going to do is I'm going to dock this robot window to the left side of my screen, and then I'm going to make the changes that I need to do in Visual Studio to move from offline mode to online mode. Okay, And that is actually very easy to do. The first thing that I'm going to do is at the very beginning of my program, right after I create the arm, I'm going to set up what's called streaming mode. And streaming mode is a mode where instead of being offline, you are connected physically to either a virtual robot, like in Robot Studio, or a physical one. And then there is a live connection of data flowing between the robot and Machina. So this is very easy to do by just saying, I would like to set which control mode I want Machina to use. And the API, the exact wording of this has been changing a lot lately. So maybe when you see this video, the method is not called control mode anymore. It's got some kind of different name. But you can look up in documentation how this is. So by choosing a control type, you can see that there are 3 different ones. This is also very likely to change in the future. So offline is the default mode that we were using before, where there's no live connection with anything. It's just the actions are just buffered in memory and then compiled to a file. But if I choose stream, then Machina is going to be set to work with a live connection with some kind of robot, virtual or real. I can use the control type enumerator, or I can simply just use a string to say I want to work in stream mode, right? The next thing that I want to do is I need to set up how this is going to connect to the robot. And this is a tricky issue because robots out of the box, they don't really come with good ways of connecting physically and to streaming. So Machina relies very often on particular programs or particular drivers that must be loaded to the robot and must be running in the robot beforehand so that they can correctly connect to that program and exchange data back and forth. This depends very strongly on which brand of robot we're using, whether if Machina can set the whole thing up automatically, or if there is some manual labor, some manual setup that needs to come from the user. And depending on which brand of robot you're going to be using, you will need to look at the documentation as to how to set this up. So for ABB, if we're working on automatic mode, there is Machina can handle all that connection, figuring out where the robot is and uploading everything that it needs to upload to the robot in order to work. It can manage all this stuff automatically. So in order to do that, so what I can say is first I'm going to set who is the manager for connecting to the robot. This is also very likely to change. So I'm going to change connect. I'm going to choose connection type, whether if it's the user who has to manually set the robot to work, or whether if Machina is the one that will be able to perform all the necessary actions to set up the robot to connect and to just exchange data. Again, this, as of this recording of this video, only Machina. This is particular for ABB robots. For other robots, you need to look at the documentation on how to do that. And then once we have said that Machina is going to take care of automatically connecting to the robot, then we can just call the connect method, which will establish that live connection, upload everything that it needs to upload to the robot, and open a live connection with a driver program that will be running very likely on the robot. And that's pretty much it. Once we are connected, at this point, Machina is ready to start streaming all these actions in real time and to have them execute in the robot as soon as the robot gets any kind of priority. So just one tiny thing that I'm going to change here is that it's extremely good practice to set your connection, set up how you're going to connect the robot, and then to actually connect. But then it's also really good practice to, once you have finished executing all the program, then to actually manually disconnect from the robot. Because if you don't do that from software, then the live connection, if the program stops without physically disconnecting, then the live connection may get hang and may not properly disconnect, and it may be harder to reconnect again, and you may need to restart the robot for the reconnection to happen. So what I'm going to do here is I'm just going to add, first I'm going to get rid of the exporting, because we're not going to export anything anymore. And I'm going to add a new key input to tell the robot when to disconnect. And I will explain very soon why this is the case. I'm going to disconnect right after I ask the user to press some key. And then after that, I'm going to add another key input to finish the program. That's it. That's all we need here. I'm going to dock this program on the right side of my screen. And then, as I said, right now, this robot by default is set up to listen to incoming connections and work live. So I'm actually going to add another. So I'm going to say here, press a key to connect, and then I'm going to perform all the necessary connections to connect to the robot. Then I'm going to press another key to move the robot. Another key for disconnecting and for ending the program. And you will see very soon why this is the case. I'm going to start my program. The console window pops up, right? And then you can see that I'm prompted to press a key to connect. As I do this, I'm pressing a key. You can see that Machina is searching the network, is doing strange things, is manually uploading a server to the robot, and something just crashed. So give me a second. I need to figure out what's going on. Okay, I think I figured out what was going on. The problem was that the robot that I was using, that I had created in Robot Studio, did not have the option of the PC interface, which is something that ABB robots need in order to communicate with computers and exchange information. It's an optional feature that you pay for when you buy a robot. So the problem was that when I created the Robot Studio cell, I had not added that option to the ones, so therefore it was not possible to communicate with the Robot Studio simulation. So I can just start Robot Studio again, and I can create a new robot station that contains that option. So I'm going to go here and I'm going to say I'm going to create a new robot, which is going to be an IRB 120 with interface, with PC interface. And then here I'm going to say IRB 120, and I'm going to customize the options. I'm going to close this thing here. I'm going to close everything. I'm going to minimize. And then as I create the new robot, I'm going to be prompted with some options, the options that the robot needs to have. So here on industrial networks, I'm going to say I need the PC interface. Actually, I don't remember which ones this was. Ethernet, sorry, let's say communication, this one, the PC interface. That's the one that we need. Here in communication, this is the one that you need in order to be able to turn on communication. So I'm going to create the new robot. It's going to take some time. I'm going to select the basic model. And then it just started here. I'm going to dock it to the right side. And now let's see if this works. So I'm going to open the program again, and I'm going to start the program. So in my console, I'm prompted to connect. And just for the sake of verification, I can see that right now I have like an empty program inside of the robot that contains nothing, and that the robot is stopped. So here in my console application, I'm going to press a key, and we can see how Machina is now just like figuring out where the robot is and you can see that right now the program changed to this thing called a Machina server, which is a module that gets uploaded to the controller so that communication is live, and that the program is right now is actually running. So you can see that I have the stop option because this program is running and is listening to actions that are going to be streamed by Machina. So Machina is prompting me to press any key to move, and as soon as I do, Machina is going to start streaming actions to the robot. So those actions that we wrote in the program. So it's first going to this point, it is going to it's drawing the rectangle, and it's now going back. So you can see that now as the program finishes, I can hit disconnect and I can end the program right here. Something that we need to remember is that I added a key pause here before disconnecting because I need some time. I need to pause the program and give the robot some time to execute all this stuff. If I disconnect it right away, then the robot would stop executing the remaining instructions. So as you can see, I can press any key to move. So now it's moving, but if I disconnect by pressing another key, the robot immediately stops. So that's why we need to give some space, some time for the robot to figure its movements. I'm going to press another key, and I'm going to. So that's how you stream data to the robot. It's actually very easy, and as you can see, we only had to change the mode in which Machina was working, and then just also add a disconnect option to the end of the program. But the rest is the exact same thing. Well, as you can see, we've created a program that where I have set Machina to stream things in real time to the robot, and then I've written a not so complex, but a program that has a lot of different actions to make the robot do different things. And then I have streamed that program as a block to the robot, and then I implemented this pause in the program to manually wait for the program for the robot to finish, and then disconnect from the robot, right? This is nice, and it starts to be a more real-time way of controlling the robot, but it still has some limitations, because the problem with this model is that basically I have still, in a way, I have predefined everything that is going to happen in the robot by just writing it at the beginning of the program, batching it as a block in Machina, and then releasing those actions one at a time from the controller, which is nice, but it's not very responsive. It doesn't give me room to make changes and make decisions while the robot is working, and then change the future actions that are going to be sent to the robot, right? So in order to improve this model better, Machina comes with a system of events that are raised whenever certain conditions are met in the robot. So for example, the nice thing about this is that Machina is constantly listening to the actions that are happening in the robot. Machina kind of knows when certain actions have been executed and are finished, and then Machina raises signals whenever certain of those conditions meet. This that I'm talking about, this is extremely work in progress. So I'm just going to show one example of those things that Machina can do, those events that you can subscribe to. But then I will leave it up to you to look at documentation and see other events that are raised at certain moments during the life of a program that is executed. So what I'm going to do is I'm going to write a new program that is going to move to a certain location in the positive quadrant. But then the program is going to be sending horizontal rectangles. So it's going to make the program is going to make the robot move in sort of like a square spiral sort of movement. But each one of the layers of that spiral is going to be sent one at a time, and it's going to be sent whenever the previous layer has finished executing in the robot. Okay? So how are we going to do this? Well, it's going to be easy. So what I'm going to do is I'm going to keep everything here in the I'm going to keep everything in the program that I had before, all the way up to when it moves to the first point. But that's it. I'm not going to change anything after that. Actually, so well, I'm going to do that. I'm also going to remove the rotation part, and then I'm going to leave the program here empty, because from this moment on, I just want the robot to be streamed a lot of layers one after the other. So if I just executed this program, so I can actually do that right now. If I run this program, you can see that it's going to connect. It's uploading its stuff, it's connecting to Robot Studio, right? And then as I press a key, then it moves to that point in space that we want here. Okay, so that's great. So now something should happen to tell Machina that we have reached this position, and then stream a new layer to this robot. Okay, so as I was recording this video, I realized that I was using an older version of Machina that did not have the event that I wanted to show you. So I actually just went ahead and compiled the new DLL and uploaded it to the library. So you can see if you go to Machina now, and you can go to the main repository of Machina, and you go to the distribution folder, you can see that I have uploaded a new version that contains the Robot Studio DLL and the new updated Machina DLL. So the only thing that you need to do is you need to download this, and you need to go back to your assemblies folder in your project and update both Machina files, so that it now contains the good DLL the events that I wanted to show in this example. So going back, what I was saying is we need to let Machina know that we want to pay attention to when the actions are completed, and whenever a certain criteria meets, then we want to stream a new layer. What that's going to be is, the way we're going to do that is by subscribing to an event that is called ActionCompleted, and this event will be raised every time one of the actions that we have sent to the robot is actually executed and finished by the robot. So what we can do is we can subscribe to this event by just adding a new delegate to this event. So we can just write one from scratch, like we're going to do right now. So I can write plus equals, and then I can press the tab key, so that Visual Studio already writes this scaffolding delegate that I can use as a function that will be called every time an action completed event is raised by Machina. If you're not familiar with event handling in C#, I welcome you to go online and take a look at a couple of tutorials. It's basically, if you're used to other paradigms, it's kind of like assigning callbacks to certain events, like it would be, for example, in JavaScript. So now that we have the delegate, this event comes with certain arguments, which are called ActionCompleted arguments, that that give us some information of what just happened. It gives us, for example, the last action that was completed, but it also gives us the number of how many actions remain to be completed by the robot, which is interesting, because what we can do is, when that number is 0 or 1 or whatever, then we can just generate a bunch more actions and then send them to the robot right away. So let's do a couple of things here. So I'm going to make sure that I know what's going on, I'm going to write here a message to the console, action completed, and then I'm going to write, or I'm going to write in the same line, action completed, and then remaining, and then here I'm going to just write from the event that is passed to the delegate, I'm just going to write remaining actions. I'm going to take that number. Okay, and let's see how that works. I'm going to run this program now. I'm going to connect to the robot. It's doing its thingy, and then I'm going to press one key to start sending actions to the robot. So I'm going to send actions, and you can see that the four of them have already been executed, because basically the robot is at the position that we wanted to move it to. So let me just go back and close this thing here. Let me just make sure that I move the robot back to a home position. So I'm going to go to layout, right click, and I'm going to jump home. So the robot is in 0, 0, 0, 30. That's why it's pointing forward, and 0. And let me try again. So I'm going to start. I'm going to connect to the robot, and then here I'm going to press move, and you can see that 2 actions are already completed. Those were probably the speed and the settings, and you can see that here the move one was completed and the wait one was completed. If we even want a bit more of data about this, what we can do is we can say here I'm going to write the action that was completed. So this guy, and this is going to be stringified, and then I'm going to write how many are remaining. So let's do this again. I'm going to start moving, and you can see that, oh well, it doesn't come with a, well, I need to fix that. Anyway, anyway, it will be fixed at some point. So now that we have how many actions are remaining, I can do something where I say, well, if the number of actions that are remaining equals 0, then I can call this other function that I'm going to write here, private static void, a new function that is going to call send new layer, for example, right? So here I can just say send new layer, and I can pass the sender, which is basically going to be an instance of the robot. Here I'm going to say I'm going to take an object of the type robot, and here I'm going to have to cast it before I use it to something that looks like a robot object. And once we're done, what I can say is, well, to send a new layer is basically saying I'm going to move a certain amount in the X direction, another amount in the Y direction, back, and then a little bit up. So I can just say arm, whatever the robot is, I don't care. I just want to move a little, a tiny bit in the X direction. So 50, for example, arm, move 0 and 50, arm, move minus 50 and 0, and arm, move 0 and minus 50. And then move a little bit up. So 0, 0, and 25. Right? Also, for the sake of making sure that I am what I am, I'm just going to write a message here, sending new layer. Right? And then let's see if this works. I'm going to move the robot back to home, right? And I'm going to now start this program. I'm going to extend this a little bit. So this is connecting. It just set up the robot to listen, and I'm going to press another key to start moving. And you can see that this is the amount of actions that are completed. There are 3 remaining, 2 remaining, 1 and 0 is the waiting. A new layer was sent, and then a new layer has been sent, a new layer has been sent, and a new layer has been sent. And as you can imagine, things, because this is happening in real time, the size of the layer that could be sent, or the shape of that layer, or whether if it's a square or a circle or whatever, could be changed according to some other information, such as user input, such as the measure of some sensor, you name it. The problem with this is that this code that we just wrote is going to run infinitely, because we didn't set any condition as to how many layers should be printed. So I could just press a key and disconnect, right? But we could embed some kind of logic here to stop this. So for example, I can say, well, I can create a static int property that is going to be layer count, and I want that to be 0, and static int max layers are going to be 5. Okay, so every time I send a new layer, I'm going to increase the layer count by 1. And here, at some point, if the number of layers that was sent is equal to the maximum amount of layers, then just take the arm, and disconnect. Or actually, much better, it would be to just unsubscribe from the event. So we can just say, well, I'm going to take the robot arm is going to be the robot, and then arm action completed is going to, I'm just going to subtract this event from the, I'm just going to remove the event from the handler. And let's see if this works. So I'm going to start, and I'm going to press key to start moving, and then we can see that it sent one layer, second layer, third, the fourth layer, and it just sent a fifth layer. And after sending the fifth layer, it did unsubscribe from the event, so it's doing nothing anymore. So I can just press to stop the program, and it's done. And that's fundamentally how you can do real-time control of the robot with the tools that Machina give you.